Well, welcome to the Dream Labs. I am Dr. Contrast Live, and I'll tell you what an absolute nightmare today this has been to try and get this thing all organized here. Let me just switch this camera over a little bit. There we are. We had some real technical difficulties. As I said this morning, I could not figure out why I came into the office, and I was working with my system yesterday, and it worked out very well. And the next thing you know, I cranked it this afternoon about maybe noon to get things warmed up and get ready to go. And everything was shut down. Mouse didn't work. The Stream Deck didn't work. The CPU was not, and the monitor was getting power, but it wasn't bringing up the images at all. So we got that all set to go. Hey, hello, Antares. How are you? Well, thank you for your patience. What an absolute nightmare the last couple of weeks or days have been here, and especially this morning throughout the day, trying to get this monitor to work. And the CP system work out, and finally we got it resolved, and we get all that resolved, and we started putting up, and then I lost my chat line, so I had to start all over again. So to bring up the speed is what took place, unawares to me, and my IT guys, very often in the building, they'll turn the power off in the building at night, and everything gets shut down, but I didn't realize that when I came in. Everything was, the power was coming to the monitor and everything was good, but the CPU that was switched off. There's no lighting system there at all, so I just cranked on the switch and it worked. But nonetheless, we got all set up, and boy, glad to be back on the air today. And before I begin, too, I want to make sure that I apologize for the delay yesterday. As I said on previous streams, I've been involved for the last 3 years as the president of an advisory board committee for a 5-state regional STEM system. We had a big secondary meeting yesterday. It was really worked out well. So, yeah, it's just interesting. So we got that all put together and got that done. So the month of May, but the advisory board piece is always busy, but we got it resolved. And I can't thank you enough for being patient here. And yeah, I agree. And you just got to cross your fingers every time we get this thing fired up. And we've got a rocket, we've got a great system in here, but you just don't know what's going to take place with it all. So, but nonetheless, here we go. And I thought I'd do a little bit of review. And before I begin, too, I want to thank you very much, Antares, for the work you put together and sending some of those sketches back that you felt were yays and nays on your text to me, or message to me a couple days ago. Just really well done. Very, very much appreciated. And I also got some from, just got yours information, but I also took a look at that information and I thought, it's going to be interesting here how we put this all together. So today, what I want to do is call this like Judgment Day. We're going to take a look at some of the things we've selected, and I've done some overlay work, and I brought some things along here just kind of chat about potentials. And I think that we're still looking at the design objectives that we talked about 2 weeks ago, but this phase 3 one is going to be more specific about how do we pare this thing down and get this into a system where we can start doing some sketch rendering work around it. And again, your input, Antares, was very helpful, and you picked some direction here that I think is very enlightening and to me highly innovative. And as I said before, I'm not concerned about having the workability problem here. In other words, from concept to marketplace, we're looking at images here or concepts that can become future think in terms of drills and power drills. And I think there's a lot of real estate there to work with and some innovation. And since I got your information, some very interesting things that kind of struck my mind about, all right, let's try this and put a list together. And I'll go through it here today, but I want to take a moment here just kind of review where we are. Let me get these sketches out of the way for the time being, and we'll go through the lineup here. So, as I said, today's Judgment Day. It's not a matter of going to do a lot of drawing here. I want to make sure we get some good briefing here and get some yays and nays from you, Antares, and other people who might be viewing here later on about the direction we're taking. So, but these, what you see here in the large circular areas, for example, let me bring this out here. This large circle one, this is one of the selections made by you, Antares, as a possibility. It was done in the vertical, but we also did one where we actually took that same shape and we moved it in that direction and went to the horizontal. So that was a candidate. So let's keep that in mind. There's sketch number 1. The second observation was a really good point of reference there was the second one was getting into something like this, where another one of yours, Antares. We put a window on this thing. Hang on a minute. Is that it? Just a moment here. Yeah. No, it was this one. The second one we were looking at was this one, where we had 2 categories, for example, where we had this form in both the horizontal and also we turned it into the vertical. So this one was actually a good candidate as well, and we turned it the other way. And then you had picked this one. This was the CODA system here, up here. And again, this is one here that you had selected. So there's some things in there that I thought were interesting. In both cases, that cap system, this one, and this one. And then going back to the number one was a very interesting, almost repeat theme all the way through. So that kind of opened up some doors about what I was looking at from the point of view of being very elusive and very ethereal for the next generation of hand drills. It's just one of those things that I think over a period of time they've gotten to the point where, I don't know how about you, but they're good, very useful tools, but they're extremely heavy, very bulky, very non-pliable, and so forth. And it's interesting to kind of go back to that situation where, this is really interesting how it all begins to develop in terms of maybe minimize it, maybe we put some more features into it, and there's some things I said near the end of the stream here we'll start talking about. But in the meantime, let's go back to these sketches just for a moment. What I did was, and then show you what happened here. There's page number one, and I'll go back and show you, for example, I took your ideas here, the pieces that you put together and marked them here, Tiras. So we took number one and said, okay, you actually showed this, you actually picked the one on the page that was much more horizontal. This is the one where, let me get this out of the way so I don't confuse you. This is page one, this sketch right here, the one you selected. And when I put that together, I'm going to get, okay, here's one as it relates to it. Here we are in the vertical. That's what that looks like when we went into that whole process. There it is right there. But you kind of modified that shape, picking up this dome system and this very organic looking shape at the base of it all. So that was a candidate that I said, oh, that's interesting. Actually, just the refinement off of this sketch, and you selected this sketch as maybe a possibility. That's a good one, I think, a very good one. Let me put this aside for a moment, and we'll go into this next one. And the next one we're doing was, going back to this page here, going back to 3A, and let's see, 3A was this page here, where we actually had this shape, Antares, you were dealing, let me get this out of the way here. You were dealing with this shape, but we actually turned it the other way, it went to the horizontal, and you picked up these forms here on 3A. You went, okay, this is interesting how we actually picked this up and went, that's good. Got to put that together again with that same system up on top here, but just kind of changing the center line so you get that to work. So there was A, and the other one you picked was this. It was the same kind of process where we actually picked up that same design line coming off the top of the shape, but just kind of truncated this thing a little bit, shortened it up a little bit, and got that form to kind of read in there and do some interesting things. So I'm not sure about the handle system here, but the actual forms themselves, and again, this barrel type cap on it was really interesting. So neat stuff. So here we go. That was another one, and let me put this aside here. Then on page 4 was very interesting. Let's put this aside here. Page 4 was very interesting because then all of a sudden we had this look where on page 4 we had this system up on top, and this was the one that Dakota had picked, and look at that, put an overlay on top of that thing. There's the actual overlay off of that first sketch. There it is up on top. Then we're coming down here on below, there it is, there, just translating, again, that same cap. And your comment, I think, was very interesting, Terrence, that maybe it's inside a ball joint that kind of rotates and pivots. That was a real key to me, and I thought it opened up a lot of doors in terms of creativity and execution for the next phase as we go through this thing. So that was one, but then we took the same idea, and this is the Dakota system here, and we went the same way, did this, went with it horizontally, went to the vertical rather. So we turned it, let's see, we'll do this, we turned it this way to the vertical, and laid this out by doing the following, same set of circumstances. Again, adding maybe a different grip system, but again, that same head on it that gave it some real impetus in terms of where we ought to take this thing. So there's the original here, and here's the actual overlay we put together based on your input that I received by email. Outstanding. And last but not least, down below, let's go back to the horizontal here. This one and Dakota picked this one, and you picked this one, Antares, which is really interesting. That we went down here and said, okay, if this is the one you're looking at, what about this? This is what we did. We took that same shape, and we actually, this is the first one we did here. We went right over the top of that overlay, and there it is right there. We kind of let's line this up just a bit. There we are, right there. So there's the original that you picked, and then let me move this up just a bit here. And you picked, and then this is where we are by adding that same shape. Brought it over, kind of abbreviated it, and come up underneath an undercut, and this could be a negative or a soft surface up the top for grip, but the right scale and so forth. Very interesting. The other one you picked out was this one. So we took that same shape, and I think we turned this thing to get that one done. We went this way, went vertically with it. Again, there we are. Look at that. Really interesting how that whole piece came together here, and opened that up just a bit. And even if it goes horizontally, same really cool set of circumstances were really neat. Let's pick this up a little bit here so we can see it, and we lay that in there, and there it is again. So again, horizontal, and again, I think we did this one was on the vertical, Horizontal, yeah. So it's the same way. We just kind of looked at it. So really interesting shapes. Look at that thing. It just picked up that line up on top, this one, and this one down below, and generated a different set of forms in it. So very interesting. So good stuff here, gang. Really good. I'm going to use these in a moment here to show you what I did. Again, this is Judgment Day, so to speak. So I'm going to put these aside just for a moment, and we'll put these over here and come back in just a few moments. So what I did, I brought along our friend here, an actual 1-to-1 scale of an electric power drill. And I just took the time to say, okay, let's do a little research on this thing. And while I'm at this stage of the game here, since it's Judgment Day, I'm going to start taking a look at some of the sketches you all have picked. For example, some of these guys right here. Oh, let me move this out of the way. Some of the sketches we did here, and start looking at biomimicry. What can we do in the animal kingdom or the fish kingdom, insect kingdom, to kind of give us an inspiration to kind of really refine this thing and do some interesting design work with it. So that's my next phase here for next week. We're going to take a look at that. But in the meantime, I thought we'd bring this along here, how interesting it was. And let me just give you some points of interest from what I see here. And if you have any comments at all, please feel free to make them. Because this is your task, our task collectively, and I'm so thankful for the input, and Terrace, and other people who've been watching here. You're taking the time to say, hey, this is good, this is bad, this is good, indifferent, so it just really makes a huge difference in the presentation side of this. Because I don't want this to be a one-man band. I want this to be a situation where we kind of work together, and it's an ethereal new problem coming in from a corporation, and giving them some really interesting ideas in terms of the possibilities. And while I'm on that subject matter too, I cannot stress enough that this is not a production piece. This is a next generation ethereal design search that they can utilize and begin to research and put together things together for them to see which way they're going to go, how they want to take this stuff. And also, before I go any further too, after this today, I've got an appointment set up with a couple of really good, strong mechanical engineers that I work with here locally. And we're going to look at some of the objectives we're looking for and see if we can kind of get that into reality here as a potential package for a future thing. So all these things are coming together nicely. Biomimicry, mechanical design systems, getting it packaging and so forth. So we have some validity to the process we're working with. And I think it's really interesting. For example, you look at the natural world, and the biomimicry is amazing. There are things like praying mantis. What is it? Geez, I'm drawing like a blowfish. The very round forms and so forth. And some of those things that are really interesting in terms of getting into squid technology. And again, I think I mentioned too, like a horseshoe, for example, just horseshoe crab, things of that nature. That we kind of look at those things and kind of manipulate those forms a little bit and develop a new design language from there. So interesting thing. So here we go, gang. But what I noticed here about this, I don't know about you, but this is extremely why we're doing this program and why this corporation came to us to develop this next generation of thought processing to change certain things. Look how massive this thing is. A large handle, large battery pack, a lot of unit up on top here, and power source, etc. The barrel type, I mean, all the elements are there, but it's still, I don't know how you feel about this, but it's still, to me, if you're going to go in a new market, begin to develop a new form, some of these paradigms have got to change. We could do a lot better, for example, with getting into some packaging, making it more efficient, much more adaptable, articulating, so forth, and those are the kind of things we're looking at. Economic, lightweight. This thing weighs a ton because of that battery. Is there a way to reduce the weight to get a better battery system or another power source to kind of help refine and really detail the design process at length? So these things are coming along, but I thought was interesting is this. Let's go back down to this. Look what happens here when you take some of those selections and begin to look at over the top of this thing and then overlay it over the top of this line drawing. Look at this. All of a sudden, when you get that barrel set up there, we're not that far away. That's the vertical. If you look at the other way and you turn it on the side, look what begins to happen here. Now, it might be a little bit more unorthodox, but you've got the same shape here. If we turn this the other way, look at this. If we go vertical with it, look what happens here. All of a sudden, it changes the entire character of this thing. All this mass can be taken off and just rotated into here and begin to package the whole thing. So, bills are pretty bulky. I don't own one, but I just trim and dribble and I would take up a lot of space with the attachments and so forth. Yeah, you're right. But then look how close it is here to this family, especially the horizontal. Let me go back to the horizontal here. But we can take all this mass down below and bring it up on top here and compact it a little bit. All of a sudden, you've got a pretty good working system. Look at that, how that just kind of And then open this up a little bit. The throat can be, this could be modified back and through here to kind of get those bits and pieces to work. Interesting part. And again, down below, instead of having all this down below, maybe it's a combination grip and battery ports all in one. This could be, I don't see any why we could not take this piece and the handle piece and integrate that and let it become part of the power source and then minimize the power source as well. So those are the things that I thought were interesting about these systems here. Here's sketch number 1, and let's do this guy. Sketch number 2. If we look at this in the horizontal, turning it over a little bit, look at this. All of a sudden, we're really close. Look at that. Interesting. If we kind of move that out there or shift it back a little bit, get that form to work right here, open that up, and it just condenses again to get that same barrel feel out of it. Could be really interesting in terms of being much more minimal, much more effective, and extremely fluid. And the same thing with this. If now we go this way, now we go this here, look at that. Same setup. Again, really compact in this. So bringing all this mass up into here, this might have to go a bit larger or bulkier, but we don't know that yet. It's still part of the process we're working with to get this thing to kind of function and operate. So it's interesting how those overlays really help to tell us, or me, that there's room for a lot of massaging and mistaken changing some of the elements that we're dealing with, the packaging and so forth down the line. And then there's another, that's 2. And let's do this. And then this third one, interesting how this guy all came together. Look at this, really, really interesting. Look at how that shape, all this can go back and compact into this. Power, switches, etc. All those elements are still there. So the scale looks pretty good from the pieces you picked up there, Terrace. So again, many thanks to you for taking the time to do that. Opened up a lot of doors, but there's some key things in this whole process that I think we really have to attack, and I'll get to those in just a few moments here. So in the same token, we took that same shape and we did this. If you rotate that and go vertical, same thing. Look what happens here. Let's get that lined up. Again, very compact, but getting all this information here into this area here. That'll be a little bit wider. Might have to open up a little bit, but to take some of the mass out of it, to me, is a really strong statement here. Let me stop right there for just a moment. What do you think, Terrace? Is this making sense? Trying to put some context into what you've done here and what the sketches have done and how you selected some of these studies to work with. So again, let's put this back in context. Let's line that up here, and let's put that back in place here. All these elements that we're looking at here, the ones that are selected from your point of view, were extremely helpful. And again, I'm sure as we go down the line here and begin to facelift this thing from moment to moment to moment, we'll get a lot more change in terms of having to beef things up, maybe change some of the section and scale and so forth. But looking at the whole idea of organizing this thing, for number one of the most key things we talked about 2 or 3 weeks ago was simply this, that the whole thing has to be extremely modular and extremely interchangeable. And we can do all that too and still make it very lightweight and efficient. I don't think it needs to be as bulky, for example, is what we're doing here in the marketplace here. In fact, over the week, last week I began to sit down and I thought, okay, contemplate on this whole idea. From a design point of view, what would a drill look like if there was none in existence? If we had to create it from scratch, what would it look like? Would it be this type of an orientation with a battery pack down below, a large handle, power source, and drill bit on the head? I don't know. But I think that's the thing that I'm looking at in terms of, if it's all new, what does the all new look like? Or better yet, what does the all new potentially like to look like? And there's some key things along the way that I think can really solve some things and open the door up for a whole new, what I refer to as a complete interruption in the marketplace, to disturb the whole thing and change it all. So that would be part of the goal from the corporation, what they're looking at. That's the blue sky part of it all. The ethereal portion is going to be very interesting. So let me put this guy aside. And last but not least, let's go back to that one sketch we just had here. This one, the one you picked, Terrace. Here it is. That's part of your package as well. Let's lay that up on scale. Now let's go to number 4. Look, this is the one on the bottom. Look at this. Really interesting how that line just lines right up, scale-wise. I mean, picked up the same form here, upper and lower, and develop. Let's get this up here just a bit more, so you can see it. And how we took that shape and came right back up on top of that thing. Look at that. I mean, it's close. Again, do we have to fill this in? Maybe not. Beef that up a little bit higher. That's okay. It's going to take the same kind of effort to condense it than it is to expand it. And I think the more we condense it, the stronger it's going to become. With some innovation in this thing could really be unique. So there was one, and then in the same motion, and still staying again horizontal. Look at that. That was a nice tailored fit there. So I think some of the shapes you're dealing with here, and Terrace and selected, were extremely, extremely powerful, very helpful, and I'm sure Dakota had the same thing. Really neat stuff here. So folks, That's where we are as far as the translation is concerned. Now, it's the first phase of translation. It doesn't mean we're there yet. It means that all I did was take some of the initial concept work that we hit here, and then took the overlays from last week that you sent in, and began to use this as like a little training ground about here's where we are, and each one with a red dot were one of the ones that were selected, for example, from the viewers last week, yourself included in Terrace. Extremely helpful. So that's interesting how it all came together here. So I just really felt that, for example, once these are all, we're going to keep these on file here and begin to refer to these sketches as we go down the line here. There's 1, there's 3, 4 is good, 4A is good. Let's get this in the right order here. We'll come back and refer to them in just a moment here. So all these pieces we're working with have got some valid systems to it. But again, let me put these aside for just a moment, and I'll bring this back in a moment. But the one that captured my imagination of all the elements, and almost every one of these had this very, very interesting articulating drill head on it. And there's something about this that begins to tell me a story about maybe there's some potential here to do the following. Let me go back in there. What we talked about here is the design objectives, which I've already noted on here. The design objectives were number 1, minimum and efficient in scale. Articulating a drill head. So that's going to move. Third step, lightweight, obviously. I mean, these things, the current marketplace are extremely heavy and bulky. You're right, Antares. Point number 4, being modular. Can we interchange this thing? Maybe some situations for industrial situations, a very hard case, and some for another for a molded case or a co-molded pills for a residential use. Those are the things that are going to be interesting to kind of deal with. Adaptive ergonomics. In other words, can it change its shape? Can it morph? Why not? They're doing that now with some of the aircraft technology, changing the form and shape in mid-flight. Why can't we do it with a hand drill? Interesting. Again, pure conceptual blue sky. No limitations from the manufacturer. What can you deliver? This is what we're going to deliver. A whole series of innovation things, hopefully, at the end of this run that makes some really interesting sense. And the last one is materials. Variety of materials. It could be malleable. It could be extremely soft. It could be movable. It can be a combination of materials. It can be all new carbon fiber and the next generation of carbon fiber. You don't know what's going to take place. And some of the nice things they're doing in the architectural world is now they're taking, for example, light-emitting diodes and actually streaming and lighting systems, neon, and embedding that in plastics, embedding it in concrete, and getting the lighting system to really work beautifully. If you look at Abu Dhabi, that whole process is taking glass and morphing it and changing it, and then they put light-emitting diodes in it, and in some cases, just vacuum tubing, and it changes the color. Could it do that in its drill? I don't know. Drilling and positive, that's all when it's fully charged and bright green, and when it comes to fade, green down to orange, down to red, and that's it. And we can do all that too. We can make those things change very quickly and very easily to do. So those are the design objectives we talked about. Now, let's go back into the conceptual objectives. From your sketches and from the input of all these guys we're looking at here, I really began to look at this and say, okay, if I take a look at this thing with this theme right here, and all of them had the same very similar presence to it. They had a head on it that was very unique unto itself. So I think that's a really good point of reference to begin to, okay, let's put a dart on that one and say, let's see what happens if we expose that and begin to develop that further. However, when we go back to this just for a moment, the conceptual objectives of this is the power source. What kind of power source can we utilize or find that brings us together with all to meet all the design objectives up on top? Now, that's why I'm going to have a meeting next week with these two industrial mechanical engineers that I've been really working with for years to get their input on what's out there to kind of minimize this stuff and make it much more palatable for individuals to actually utilize and use and put in the marketplace. Point number 2, it's malleable. It has adaptive shape. Can you change the shape? Is it done so, for example, either by touch or with heat or hand gestures? Can the shape of that case begin to move and become malleable? Can you adjust it? That's point number 2. That's conceptual. And I know it's far stretched, but it's still part of the possibility. Third point, it's wearable. Interesting. Instead of gripping this thing, for example, look at this. Instead of having this big, large grip on this thing, why can't it be wearable? We actually wear this thing, and it's all touch control on the inside. Where the aperture is, and you get your hand into it, and you do this whole thing where you actually change just the direction of your hands to kind of high speed, low speed, up, down, and those kind of things could be really interesting. Brings back a memory we did for some Corvette work years ago, where we actually did an instrument panel where all the controls, where you actually put your hands into the actual steering component, and actually fingers will actually activate some of the elements inside the steering control. Why not do that with a drill? You don't actually grip it, but you wear it. That's an innovation, and it's also conceptual in nature, and it's future think, but why not? That's why we're here. Last but not least, and it rotates. This is the one that got me the most, the rotational side of it all. It got me from the point of view of being extremely inspiring. This element right here tells me that thing, like your point's well taken, Antares. Let me bring this in just for a moment here. Your point in this area here is really well taken. You made a note about maybe it has a ball joint that it rotates in. I say maybe is great. I say let's look at that and analyze that as a possibility. It could really be interesting. So that's a feature that I'm going to really kind of concentrate on in the next couple of sketch rendering systems and going through the skills of making some massaging further details from the ones you've submitted over here, for example, from this stack. The ones we selected, like this whole family of forms, and then everything else in between here, begin to look at those and begin to develop more shape and more conceptual studies based on that input. So let me put these aside for a moment here, and let's go a little further with this thing. Let's get this out of the way. So those are the conceptual objectives, and I don't see any need to kind of change those things, what they're doing, but let me go back just for a moment here. What's interesting about this design of conceptual objectives thing, based on that concept of the initial phase 2 and last week's stream, what are the next variations going to look like in refinements? And the thing that got me the most, and again, going back to what your comment was, Antares, about this ball joint, I did a series of little thumbnail sketches here. I want to open them up here just to get started. Here are some things, for example, that I looked at in terms of what if we took an example of getting into this whole rotating system, where not only does it rotate, maybe it's exposed. Maybe this is a spherical process that has in it all the elements that we need in terms of maybe switches, control, power, stop, still changing the angle or direction. Some of these things can be really interesting, for example, and putting it all together. Now, to me, this becomes a very interesting feature. That's a great feature. Some of these things around it, not quite happy there yet with some of the packaging that we're looking at as far as the overall tailoring of the actual body of the case itself. But let me stop right there for a moment. And Tara, since you're viewing here, anything here that strikes you? Are we on the right path? I mean, I'm not saying we're right here in terms of the overall shades, but on the right path with this rotating head and something that does really unique and gives you some axis change. It's good both in the horizontal and it's good both in the vertical. That's what really inspired me from your input from last week. Let me stop here for a moment, hopefully get some input from you. What do you think? Is this too far of a dream? Too much of a stretch? I mean, it's pretty bare naked now. It's just kind of exposed, but massaging it and making it more of a design statement, not to make it pretty, but make it functional. Could be very interesting to put it all together. And again, biomimicry is going to help us solve that problem. There are things out there in the physical world, the natural world, that can kind of really tailor this in and make it a very unique set of circumstances. Let me stop here for a moment and hopefully get your input. By the way, while I'm waiting for that too, these are basically elevation studies, one front end study and so forth to put it all together. Again, first start at getting this whole idea of conceptual objectives, strictly conceptual. What if? It's the who, what, where, and why phenomenon. Who are we doing this for? Why are we doing this? What's the object? And when are we going to reveal it? So that's the whole idea behind the whole process there. Anybody, what do you think, Antares? Just take your time. Your input and others along the way are very, very valuable. I can't thank you enough for the things you took time to do that. It was great. Inspired me to see it from a different perspective as well. Oh, let's see. I think it makes sense as a concept, but I'm not an engineer, but I think the tech exists to have a drive shaft for the universal joint that allows it to turn the corner. For example, I don't see why not. Yeah, I think that's part of it too as well. This whole thing could be very captive in terms of being, but the stem behind all that could actually form the rotation for it. And I think the one that intrigued me the most, if it's possible to do so, and I think we'll look at it from the point of view of having a couple of my associates look at this thing from a mechanical point of view, just to give it a little bit of credence, is the one that got me the most was this guy right here. We actually have an actual shape like a donut, and this thing actually travels on an orbit, or it actually changes its scale. And you can actually detent that and mark it off in the actual case itself to kind of show you where that angle is and how to prevent that, how to make that much more manageable. Have you ever been in a situation where you try to get into a tight spot, and because of this very large mass here, you can't really rotate it or work with it and get it in the right place? That's one of the reasons that I picked up on this whole conceptual and objective piece. It kind of does it have is it minimal enough to be able to handle both, in this case, for example, in all cases, the vertical, and does this thing rotate enough to give you, for example, just by changing your hand gesture, go from vertical to horizontal, but yet get into a small, limited space. That was the idea behind this whole idea here. So I think you're right there. Again, some engineering people look at this thing and say, okay, what do we do to make this a little bit more feasible? I don't want to captivate it in terms of making it right or wrong, but what's the idea behind it all? Can it happen? And I'm pretty sure it can, because of the drive axle and the drivetrain. All that might be more of a bulk and behind the head itself, but it's going to be part of the process with it. Well, that's cool, having the head itself travel to a different point. That's the point. That's what I'm getting at. I think that's from your point of view, Interest. Looking at all the ones you put together. Let's go back to these sketches for a moment. Every one of these sketches that everybody selected had that feature in it. That was in there. That told me something about this whole. I really thought that was interesting to have that as a feature. But how do you employ it? What's the next generation? What's the next variation on theme? And I think that's what we're looking at here. The next variation in theme is to go back to this sketch right here, which this one caught me. I did a bunch of those guys. These little studies just to kind of see, okay, what happens if we put this thing out on a limb itself? It's a little bit on the bare side. It's a little bit brutal looking. I don't want to make it pretty, but it has that certain function. But I think this thing, whatever that drill head does, whatever happens up front here, that thing travels on an orbit or a scheme that changes its whole attitude. So the head travels. And you don't have to worry about moving your hands. Maybe just by shifting your hand, it goes from horizontal to vertical, but it's still minimal enough to get in some really tight spaces. So what do you think? Do you think that's valid? Having the cool head travel on a different point on the tool? Yeah, I think that's doable. What do you think, Antares? Thumbs up or thumbs down? Interesting, very interesting. Now, while we're on that subject matter, this little thumbnail study shows a lot of travel from, let's say, 180 up to maybe, again, vertical 180, but it could go horizontal, 15, 30, 45. That could do it. It could be that whole idea. That's the concept. I think that's a great concept to work with. Now, is it doable? I think so. There are mechanical presses, for example, in automobile machinery, for example, repair work. They've got pivoting heads on wrenches and certain drivers. Why not in a drill? And why not make it in a situation where you've got something, for example, that's viable to make it much more cosmetic in terms of being less bulky. You don't have to worry about the battery. The whole thing is placed in there. The whole idea is placed in it, and it's all compacted. And again, I'm intrigued by the fact, and now kick me if you choose to, but I think the one that really inspired me the most was, all right, if this thing moves, if the head moves, why would you want to grip it? Let's wear it. Let's put it like a glove. It actually has an amorphic shape to it, and it's malleable. That you're wearing a glove that has this power behind it, and it changes its chemistry as you go from one area to another. Why not? I think that could be very doable, extremely doable. Now, the design side of that's going to take some exploratory sketches, and that's why we're here today. As I said at the very beginning of the presentation, this is more of a judgment day. What are we looking for? What are the objectives from the design side, and what are the objectives from the conceptual side? Once we get those two to meld together, then the sketches are going to make much more sense. And I'm going to bring along for next week some examples of not only this stuff, I've already got this in for that very, very purpose of showing how massive that is, but look at the combination of this to this. Two different schools, but nonetheless, all of that and that is captive in here. It could be captive in here. It could be opened up, could be stretched a little bit. That doesn't matter. What matters now, let's see. There have certainly been times where I can't position the drill at the correct angle due to space constraints. So this function in theory would be I think absolutely correct. I mean, that was the motive behind it all, to give you much more flexibility for tight spaces, open spaces, horizontal or vertical, above or below. It's extremely adaptable, and that was one of our design theme, for example, design objective. Make it adaptable to the environment you're working within. You can also adapt it to a commercial side where it's very industrial looking, and also a commercial side where it's very friendly looking for family members and so forth. So there's a lot of latitude here that can be very, very intriguing. So the translations now are going to be much more sensitive in terms of making sure that we can get this thing in the right place and really send out some signals that this is the next generation to disturb the marketplace. We're going to hopefully when it's all said and done, this object or this project, my approach is going to be like, I know it's going to be far-fetched, but it's the truth. I'm looking at this program for power drills like Apple iPhone did the telephones. It just disrupted the entire marketplace. No longer did you have a big, huge receptor. It was a little thin plate that had a computer involved in it, which is interesting. Why not here? You can have computerization to power it. Why not? AI. And again, that's one of the reasons why I'm going to my engineering friends here to kind of say, okay, what do you think? What are the sources we can work with to make this much more viable? So just neat stuff. So thanks very much, Interis. That input is great. Yeah, I mean, having the head move to me would be really interesting. Now, does it look like here, just up here, a sphere? I don't know, but if we captivate it, one thing that what worries me is when you captivate this thing. Let me just show you real quickly what I'm referring to. If you captivate this, just for what it's worth, when you captivate this, if you have an element, for example, that's spherical and it does the following, and then you come back into that and you find the center line of this guy. And you've got that. Then you begin to captivate it and put it inside a barrel. Now you could do that, it'll still move, but it's going to restrict you by going horizontally. You know what I mean? Let me beef this up just a bit here. If that comes in and there's a cap around it, like that, and it comes off to a chute of some sort, some kind of a neck, and then your center line is here. But if this thing rotates, let me just get this here for a moment. If this thing rotates inside that cap area here, let's get this. If that rotates inside that area, let's kind of thicken this up just a bit. So we've got a little bit of airspace in there. If that works through there, that might work. But the thing that bothers me is if I rotate this thing downhill, but if I rotate this and start here and going downhill, that portion right there is going to get in the way. So maybe it's much more of a shape where it actually rolls over and does this, almost like a chin. So it's section-wise it does that, and the thing just sits inside that area, and it rides inside this area with a gear. It changes location horizontally and also vertically. So does that make sense? It's a small sketch. I'm sorry about that, but it's just the idea of getting that put together. So when you put it all together, is it, for example, this shape? Does it do this? And then does it come into this? I mean, let's find its center line. Does it start here? Is there a point of departure there for arrival and a point of arrival here? Does that thing now do this? Is it concave? And then this thing sits, and it's got a little more shape to it. Like it doesn't have to be a sphere, but it's got this kind of form to it. And then it's got this, then the drill head itself, and that sits in here. And then that whole power, that whole thing goes up, north and south, and at the same time rotates in the other direction because you've got some flexibility to work with. That would open that up because this thing would could actually pivot from right in there and rotate up. I'm not so sure you could do that. However, if you keep it in that position, why not go both horizontally and vertically? Just by turning the head itself, that would turn into, for example, that would be vertical, and horizontal would look like this. That same process, but then you got the storm goes around it like that, and there's your center line, so to speak, real loosely, and then there's the actual head doing that, and it still fits inside that whole paradigm. There's the actual drill bit portion here. It would still travel horizontally as well as vertically. So it's interesting. Yeah, I understand. You will limit the range of motion developing what kind of housing you build. Yeah, that's it. Around it. I would prefer, for example, if we could actually make this thing minimal, like we've done on some of these sketches here, for example. We go back. Yeah, if we keep that head area, using your sketch here, Antares, if we keep that head area really minimal and yet pivotal, that could be really that's the secret. But to actually trap it inside something, and it might be a little strange to have that thing just be a pure sphere. Why not? Well, here's the actual head, there's its connection, and here's its center line. And we have the center line here, and we come off of that with this, the actual head, and then actually this sphere stays inside that, and this comes off the neck comes off of that and does this, and this is where the gap is. Oops, let me turn this out for a second here. And this is where the gap is, and through here. That gap isn't here, but it still holds itself inside. There's a mechanism here that holds that gives you enough pivot room. It might have to come back a little bit less, but nonetheless, there's something about that really says that's really intriguing. Here's my connection. Oh, I probably it's out of the way here. Here's my connection. Here's my drill bit. That chamfers in. And then here, you can have a series of spots. 1, 2, 3, 4, 5. You touch those areas and it begins to rotate to where you need it. And then out of here, and you've got this coming there, and then all of a sudden the drill bit comes inside there. That could be very interesting in terms of keeping it open, and yet surrounding it with an interesting shroud or a shape that begins to, maybe it's this. Not so intrusive, not pretty, but nonetheless, some idea where you have this, and this could all be gripped down below. This could be all power source, power module, switches locations, soft co-molding, etc. But the shape changes. It gets much more amorphic, quite basic, but could also be iconic design. That's strongly communicated. Yeah, I think that's it. To me, the whole secret is to keep that sphere intact. There's something about that I think really makes a huge difference. And again, if you go back and go this shape, and you go maybe circular or compound form there, and begin to put that beauty out there on itself, and connect that dot into here, and take that shape into it, and somehow develop a form around here that really makes a big difference in terms of being. And this is something. In the other view, what about this, where you have that stays where it is, but we talked about wearing it. Maybe this attitude here comes in and does this. There's a little aperture here, and then you put your hand inside that, and in the front view, you've got the basic shape doing this, but the actual pocket swells up and it gives you enough room to get that thing. This is all soft, and then you put your hand inside that and you begin to move that. Does that make sense, Terrace? Another. Let's open this up. And then you've got that drill bit sitting up on top here, and then you wear this beauty, and all else is all cosmetic. That could be bulged out a little bit more, give you more room to work with, but your hand fits inside that. And when you go back to that, in the other view, maybe it's much more of a parabolic curve, like so. And it's got this pocket in it that comes across the top of this thing. Maybe the pocket stems out and has you, and this is all in section. This goes through, and this actually flares out and gives you that grip area. So kind of really interesting, I think. What do you think? Let me put this together. Terrible sketches. Yeah, I think the glove side could be really interesting. I think so. You think that's a valid approach? The glove and the actual head. As I said, this is Judgment Day. This is really helpful, Antares. Great. You think that's possible? I think it is. I mean, why not? Our task, again, is to really create something that's completely new and, shocking. Why not? So is the iPhone. This could take away all that mass, for example, of that sketch here. This always bothered me about this guy right here. That thing was just so huge. But if you look at that, let me see if I can get a sheet of paper here handy. I don't know if I've got one. If I can see through it at all or not. But if you took that same form and you did this, there we are. Try to get through this to work here. But if you took that same shape on the horizontal, yeah, we can see that. That's good. Let me try something here real quickly here. If we can take that same shape and get that sphere to work out here, then take this whole mass, open that up, keep that open, let that travel, then take this whole shape, which is down into here and here, and open this up. And create this glove. And this portion is on the inside. And that section comes in and does a following. But that's a little rounder. And this portion steps right out there to give you that glove. That's a section change right there, where your hand goes right inside that form and to work with it. Or it could go the other way. Actually take that same shape and reverse that so it comes out here. Maybe that gets a little bit larger, opens that up, and you take that around and just begin to develop this whole glove, this whole idea of this very interesting glove. Then the actual form itself is in through here. This is all power. This is all grip. That could be a whole series of stations where you can actually take a lid in this thing and put small drill bits in there as packaging. Interesting. What do you think? Let's see. Let's go here. And this comes into the drive mechanism here, and that stays, and that. This gives you the whole idea of being able to rotate that thing. Look at that. You're wide open now. Just to clear that just a touch. That goes up and down. And also, same way. Horizontal and vertical. Really interesting. I don't know. It's a rough sketch, terrible sketch, but we're just thinking out loud here. What do you think, Antares? Worth pursuing? I think it is. I mean, it's from your sketches and from everybody's viewing sketches. I mean, you guys put that together terrifically. Anybody? What do you think? And again, if I were to complete that, let's see what you think here. I guess there's the ergonomics of making sure different size hands could fit inside. You could perhaps put a shell that closes around the hand. Yeah, I mean, that could be portable. That could move. According to the other view, you're going to have this in the static position. Here's my center line of the form. That could sit in there like so, actually like this, Antares. And then as you grip it, this thing actually moves out and gives you a lot of, that's flexible. That can move out and expand. So this thing can actually move. This stays static, and this is adjustable. Interesting. Again, another innovation. I thought about that and putting this whole hand thing together when I put that design conceptual objectives together about the hand control. And even there, maybe that thing stops inside that and begins to see inside this is where the hand comes in. You've got all this bank of switches on the inside that are very touch controlled, but they give you an idea of where you are. Or else you just squeeze it to kind of get the power you need. Maybe I'm making it more complicated than it needs to be. Not really. I don't think that's complicated at all. I think that's part of the process where you actually make this thing tailored enough that actually starts here. There it is in a static position. As you power through it, it opens up and gives you that glove appearance that your hand fits in there and it doesn't become an intrusion. It's all part of the process. There's nothing silly here at all about what you're talking about, Antares. That really works. But again, the idea is to get that mass down so you're doing this. Let me just sketch here for a second. If that's the case, now you've got this, doing this. You've got the sphere out here, the actual head. And then maybe that grows off of this. That comes in and gives you a lot more latitude. And this could be even interchangeable. That can change size as well. So again, when you've got that down, let me get this back in place here. Maybe it's just a simple matter of coming back and through. Maybe a lot more slope to it, a lot more glove to it. And it comes out of that shape. And then this comes back and repeats itself again and gives you more of that kind of a form. So it's much more elongated, section-wise, and then section-wise. It just stops off. Totally different look. Totally. And again, your hand can come around the top of this as well. So dual purpose. So what we get here, in essence, is a simple form where you've got a shadow that rides across in that form. So it kind of envelopes that whole form. And again, even here, you can have something on the end cap. As I go through, that could be actually in section more of that. And this can be much rounder. So there's a variation theme. So you look at this from the other view, you've got this coming into this, which is much more that shape, almost a diamond form. Then that glove comes off of that. It'll be really, I mean, it's just interesting how it all begins to come together. Let's see, another question. Kind of visualize how you can distribute the electronics throughout the wearable shell to eliminate the bulky battery. Yeah, that's what I'm trying to visualize as well. How would that begin to function to get that thing to kind of come through the processor and make this thing become much more viable in terms of being able to rotate and move in both horizontally, like we did with that one sketch here, that it actually moves vertically on a track. And the other thing we could do too is make a statement out here that this track could do, let's do this. That track could come out here and we're going to pick up this and pick up this. And that's where the track is. Again, with that same glove. Was that one sketch here? Yeah. Back to this sketch we did earlier. That's what this one was doing. It's running on a track. So that still could be valid. Maybe there's too many stations here, but we started with it at 90 or 180, then went up to 45 or 15, 30, 30, 45, 30, 45, horizontally and vertically. That might do it. So I think really, basically, that's what I'm after here today, was to really kind of chase down some of these objectives in terms of what we're looking at, in terms of, all right, here's the idea. And we've got this concept going together with this whole new innovation. And I think today, like I said, Judgment Day has been very interesting because we're looking at the possibility of changing the paradigm to again, let's go back to this guy for a moment, changing the mass overall. When you look at what this is doing, as opposed to what that is doing, or even that is doing, totally different character, but getting it all the pieces to come together from a reasonable point of view and a rational point of view. Let's move this over just a bit here and get the sketches on board. So it's A to B, in between maybe, I don't know, we'll see what happens here. But the idea is to get this whole conceptual objectives now and begin to function for us. So to visualize this thing actually as a wearing system, especially a grip system, not impossible alone to deal with. So my task is now to look at some things between now and next week to really kind of put some pieces together in terms of here's what the ergonomics is telling us, here's what the physical world is telling us, using biomimicry. That biomimicry piece we choose is doing this. Why can't we take those same adaptive habits and put it into a power tool? It can be done. It's the same thing that they did with the Apple iPhone. They took a chip and just put a case around it, and that was it. We can do the same thing here with this. Get rid of all that mass and then captivate all of this and this inside that area right there and give it the same kind of product to work with there. So I'm going to call this a day here, folks. I just want to introduce the whole idea about Search Day and tell you where we were as far as process is concerned. And again, I can't thank you enough, Antares. These sketches that you brought along here, let me turn this over a bit here, get this out of the way. Those sketches you provided, for example, that you put together and said likes and dislikes were extremely helpful. But the thing that got me the most was this whole idea of this spherical thing, this captive ball that does the job. And it moves on the surface, and you wear it. That's a possibility we're looking at for next week. So I'm going to start to develop some concept sketches based around that. Next week, we'll be a lot more interactive. We take a little bit further into phase 4 and really kind of refine, again, some of the translations before we go into applications. And then, again, some nice final renderings of what this thing might look like and get it out. And in the meantime, I might send some of these sketches off to the individuals at hand and see what they think as well. So we'll see. We'll keep you posted again. But and one last note too, Antares, before we sign off for today. Your empathic sketches look great. I think I told you we didn't have a chat line the other day, and I think your work is just so much stronger. Those empathic sketches look bold. Their strikes were neat. Much cleaner, interesting thing. Just interesting how it all comes together in terms of your empathic sketches, and I think that's going to translate into your product design and architectural sketches as well. Take that same thought into those other areas, Antares, and I compliment you for the great work being done. Huge difference from where you were about 3, 4, 5 months ago. An enormous change here. So great work, and anything you've got, send it along. But I think the work, even your toning, for example, the shades, some of your understanding form. Much deeper. Not saying you didn't in the past, but now your understanding is opening up because of all the empathy you're starting to solve in terms of, oh, this is positive, this is negative, that's solid, this is ethereal. Great stuff. The thinking process changes, and I'm not going to change my mind about that. When I started working with this whole thing, this whole process of empathy, everything opened up. It's a whole new vista of seeing things from a totally different perspective. It's internal, which becomes external. And when more external it becomes, the more internal you get. So it's a two-way street. Keep up the great work, and thank you for joining me today. It's always been a great. I'm sorry for the inconvenience of the delay. The power was shut off in the building. We couldn't figure out why the monitor wasn't working. We got it all resolved. Then I lost my chat line again. Had to stop the stream and start again. Just one of those days. But thank you for your patience over the last few days here, folks. No, the compliment is sincere. Just amazing what you've done here. Very sincere. It's not just lip service. You're doing some great work. And it's going to get more powerful the more you work with it, and the more you apply it to areas that you just enjoy, like architecture, which we're going to do next as an empathy study. It's going to be really cool to see you come together with this stuff. So, again, thank you for your time. Everybody who's viewing here, if you watch it later on today, again, thank you for the inconvenience or being patient with the inconvenience of having this thing set up. But we got it, thank goodness. And I hope all of you have a tremendous week. I look forward to seeing you next Wednesday. And again, please visit my website at drcontrast.com if you have a moment. And also drop me a line, for example. If you view the view today, for example, or the program today, along with Antares, feel free to send me some information about what you think about this whole idea about the sphere and the glove system. And others individuals might watch it later. Feel free to drop me a note of yays and nays at jim@drcontrast.com. I'll answer them right away, and it's really been a lot of fun to work with you today, guys. So looking forward to the next generation. And I think the task for me, again, and quick review, take a look at the progress we made today, the transition, phase 1. Transition 2, for example, next week, we're going to go into biomimicry, go into some mechanical device things, and look at some things in the physical world that'll help us put together based on that whole idea of this conceptual objectives. And before I close, here are the conceptual objectives one more time. Power sources, critical. Malleable, does it move and adapt? Second, is it wearable? It's ergo factor. Great. Does it rotate? Yeah. Does it move along the surface, or does it pivot? Those are things that are extremely conceptual, and I think we're going to chase that thing down and get some good professional input on how to and why, and get that to rationalize. So again, folks, have a great week, have a tremendous weekend. Enjoy yourself. Be careful, and we'll look forward to seeing you next Wednesday. And I'll close with this. It's about the most important part of the stream. Never forget to dare to remember, to dare to be great, because you are. Thanks very much, gang. We'll see you next week. All the best. Bye-bye now.